Okay.
Okay, so this is a classic case where you have to get both sides in standard form. The right hand side here is already in a standard form. So you can say this is already in a standard form. This on the left hand side needs to be converted to standard form. So standard form is ax squared plus bx plus c. Okay. So the first thing we'll do with the left hand side is we will distribute, and this will become ax times bx. So that's abx squared, and then 7ax, and then we need to distribute 2 times bx, and then 2 times 7, 14. And then you have to collect the like terms. So x squares terms together, x terms together, and the constants together. So what do we get? After doing that, we will get AB as a coefficient of x squared. Then we'll get 7a plus twice b as a coefficient of x, combining these two terms, and then the constant 14. So now that we have the left-hand side as a standard form, we have to equate the left with the right side, which is already in a standard form, which is 15x squared plus cx plus 14. And then you have to equate the coefficients of the like terms, meaning ab has to be equal to 15, 7a plus twice b has to be equal to c, and 14 equals 14 gives no information. So we can write c equals 7a plus twice b, and we can write a times b equals 15. And we also have a plus b equals 8 as a given constraint. So now we have three equations, three unknowns, a, b, and c. Theoretically, we should be able to solve them. So the easiest way to do that would be just start with a times b equals 15 and look at all the answer choices that look like they're integers. So I'm going to assume that a, b are integers, which is not necessarily stated in this problem, but looking at the answer choices, there's a good chance they're all integers. So I can do 3 times 5, a3 b5, or a5 b3, or a1 b15, or a15 b1. All of them have a product of 15, but a1 and b15 does not satisfy a plus b equals 8 constraint. So 1, 15, 15, 1 are out. So we are left with either a equal to 3 and b equal to 5, in which case c would be a3 b5, which is a 31, or we could do a5 b3, in which case c would be 7 times 5 plus 2 times 3, which is a 41. So given these constraints, the two possible choices for C would be 31 and 41. And this is a very common type of problem. Whenever you see this, make sure that you convert both the left and the right into standardized forms, which are ax plus bx, x squared plus bx plus c forms. And then you have to equate the coefficients of the like terms, equate the coefficients of x squared, equate the coefficients of x, equate the constants. And there may be more complicated polynomials, like there could be an x cubed term, there could be an x squared y term, there could be an x y squared term, there could be a y cubed term. It doesn't matter. You have to basically convert both sides into polynomial forms and then equate the coefficients of the like terms, and that will set up a system of equations for you to solve.
Right. I think that was the part that